4 years ago, MINIWIZ started a journey to create the first mobile recycling line, the Trashpresso. Using press machines, shredders, ovens, and other industrial equipment, Trashpresso is able to recycle trash anywhere. While TP1 traveled around the world, MINIWIZ developed a new generation of Trashpresso. A modular system with a smaller footprint for easier transportation and higher energy efficiency. The next iteration of Trashpresso is able to turn your trash into products faster than you can finish that espresso. With the new system of heat induction presses and specific molds for different parts, the process has become faster and more efficient. The new Trashpresso complements Robin, MINIWIZ's smart trash collection system, designed to work with the next generation of 5G networks. We will track every single piece of your trash from the moment you throw it away till the time we put it back in the game. IoT is the core of our new system. Furthermore, new Trashpresso can be upgraded with a robot arm that will do the dirty job. Technology, engineering, design, ingenuity, creativity, and passion. This is Trashpresso 2.0, the mini Trashpresso.
I mean, earlier speech was really touched my heart because the urgency is what we are aiming for, this anger to do something quickly. And I grew up in the States, educated in the States, and I just got so angry at so much talking about circular economy. I almost think circular economy is a dirty word now, okay? And then I think the last word really, maybe that's why we work with Nike. That's why my shoes, just do it. So you see all the stuff we have been doing is about just doing it, okay? And then the next thing I think it's also very interesting is, I want to show you today, everything that is beautiful, comfortable, can be made already 100% from post-consumer waste. Okay, with less energy footprint, less water footprint, and higher efficiency. Except, I don't think our current education system is capable of doing that. Okay, the teachers are not equipped, students are not equipped, the people who study design doesn't care about engineering, the people who does engineering doesn't care about design. Okay, and then so this is one of the issues to how do you cross silos. So for example, the video you just saw, it's a system that recently just launched in Singapore, about literally 2 weeks ago, okay? And we are going to have a lot more of that system across China, okay? You're talking about scaling potentials. It is already scaling, but not in Europe. I just want to say that. Why is that? It's actually behind in circular economy because they lost the manufacturing system. They lost it, okay? So you cannot touch the chemical. So I'm actually very happy that GC invited us for this event because you gotta think about Indorama, GC, but and then, you go to Europe, you get 2 types of recycled polyester yarns. They all come from here. Indorama yarns, and Far Eastern yarns from Taiwan. Doesn't matter it's short fiber, doesn't matter it's long fiber. But why do you ship the trash from Europe to Asia, then process it into a yarn and back? Can we do that locally today? So that's what the system is doing, okay? Trying to incentivize new generation of collections into currency and into new generation of products. But how do you power all this? You can build a kitchen equipment, but without a database, it doesn't work, right? Just like a computer, without a software, without a program, it doesn't run that. So for the last 15 years, I've been in this business for 15 years, we've been collecting materials, application data, okay? What trash material can turn that into? You need at least 4 mechanical data in order for you to do any type of digital simulation from the very beginning. You need a MI, you need a mechanical strength, impact strength. How else are you going to know what this trash material can turn into? I love ocean cleanup. I also hate ocean cleanup. Why is that? Because you have people cleaning up the trash but has no idea what to do with that stuff that is being collected. Okay, where did that data go? Okay, it has PP, HDPE, it has PET, it has lots of PVC in it. But how do you know which data, what type of degradation can it be turned into, what type of pressure and heat? Also, we try to do mechanical recycling through this data, not chemical recycling. So you can do decentralized recycling. But I just want to show you how beautiful it can be, okay? 10 years ago, we built this with Nike, and the current shoes I'm wearing is actually made from recycled polyester bottles, okay? That is actually going into a Stoll knitting machine. Who come up with the specs for Stoll recycled polyester into a knitting machine? Unfortunately, I'm the one who's standing here, so that's why we came out with that specs, okay? So then you market it for Adidas, you market it for everybody saying this, but you gotta know the new resource efficiency. Maybe Adidas sold the ocean plastic shoes for 5 million pairs in a year. Guess how little material it uses? It's 13 grams per pair of shoes. Just imagine if GC wants to produce that. I think you will be losing a lot of money too, you see? Okay. So this is the new resource efficiency. You see, there's a huge amount of what we call scale gap. Okay, the more efficient you are, the less material you need, actually. Okay, so this is, for example, that's how we get into architecture. One of the solutions we figure out is you need to take recycled material into architecture. That's a new reservoir of material. So for example, this is all made from recycled polyester. Tension and compression, I study structure. So the whole forces, doesn't matter what forces you have, the whole forces can be turned into just tension and compression. So all the tension and compression is all made from recycled polyester. And then we want to show you that recycled material can be 3D printed. So all the fixture in there is 3D printed. Okay, wow. People think there's some rocket science. This is really the dumbest crap you can do in the current recycled material system. So all the ceiling moves, it actually moves, so, and then all the fixtures in there are 3D printed. Okay, we've done that. It's possible today, okay? Can we create a basketball stadium that's 1,000 people with Kobe Bryant, LeBron James, the highest paid basketball star, has a portable basketball stadium that travels around Asia, okay? And this is possible with the polyester. It's using a crane with no foundations. Can we do a fashion line with recycled material? Unfortunately, the line is not continuing, but there is a pair of shoes called Nike, Air Max, Arthur Huang shoes. Okay, but it's actually, this is actually sold in the US, in New York. It was actually sold out in a day, okay? And it shows that recycled material is possible. So what's interesting is we're using a classic silhouette of a shoe, and the packaging is also made from 100% recycled polypropylene. Okay, so it has no glue, single material. It can be re-recycled again. It interlocks without any glue, so you don't need shrink wrap to wrap the box. And then inside, one box, it fits size 5 to size 13. Can trash material fly? Yes, it can. We built an airship, recycled PE and recycled polyester. How can you build the lightest footprint buildings for Cristiano Ronaldo's shoes for the Nike soccer cleats? Can we do office ceilings? This is in New York. Office ceilings, insulation panels, fireproof, B1 rated. Every office can be different shape, different size, and linking that to the storytelling of every office. Tokyo, from floorings to the different type of panels, all the way to the Nike shops around the world. Okay, so you say, can it get into retail? Is trash material good enough to present luxury products? Yes, it can. It's in New York, London, Paris, Milan. Okay, we collected shoes from recycled Nike shoes. We turned that into store fixtures. This is Tokyo. And this is the latest one in Shanghai. It's called House of Innovations. Okay, so you see new generation of stores use very little material. I just want to say, very little material. It's just LED screens now. Okay, so this is an experiment we recently did. We collect only materials from the inhabitants around that local regions. Okay, so we try to prove that everything in there is collected locally with the celebrities. Okay, so you can imagine how many Instagram there is, how much. You see the chairs, the carpets, they're all from celebrities. From the celebrities' collection of shoes, we turn that into chairs, turn that into carpets, turn that into ceilings, turn that into walls. And can we do the production locally and create that stores on site? And we also did that. Okay, we create them. We have a factory literally trying to press all the stuff together locally. Another thing is, I know when you see a lot of interior projects, the people is like, oh yeah, can you do that with bigger buildings? Yeah, well, I mean, we started off building big buildings, okay? This is 10 years ago already. This is EcoArc. This is how I got involved with National Geographic. This is one of the first National Geographic documentary on us. And this is 1.5 million PET bottle we collected from a Taipei citizen. Every person can come in with 20 plastic bottles, and then we gave them a olive oil from Italy in return as a gift. Okay, and then we created this whole structure. And even the steel bone in there is actually made from the highway scaffoldings. We recycle from the scaffoldings. That's why it's so big. Okay, and this is, I know, like people would be like, is it fire safe? Did it pass yes, it is. It passed all the building standards, lateral loading, fireproof. And what's also interesting is pass a Gabi analysis of a LCA analysis based on the carbon tray in Europe. Okay, and this is a result of that test. Okay, so this is resource efficiency right there, right? Carbon footprint reductions compared to a classic glass building versus SiO2, which is air pollutions and water pollutions. And that is what we are striving for. And we should get even more efficient on that. Can we turn cigarettes, into an air purifier? One of the biggest ocean pollutions is cigarette butts. Okay, in terms of items to collect in all the beach cleanup. And that is actually cellular acetates, and we come up with a machine to be able to take just the cellular acetate and we turn that into an air filter across Italy. Okay, so this is, next time you go to Rome, you're shopping next to Gucci, maybe you can take a look at these very innovative gallery, but at the end, still selling cigarettes, right? Okay. I also want to show you the chair. If you focus on the chair of this presentation, the chair is actually made from the leftover of that production and recycling process, which is the paper and the tobacco. And we turn that into boards. Okay, from that board, we work with a famous architect I respect in Italy called Cesare Leonardi. Okay, it's using these boards and turn that into these 100 different pieces of furniture, chairs, okay? So it's about local design and local creativity, okay? And we also do a lot of stuff with Jackie Chan. They're one of our biggest supporter. And on his own projects, for example, like this is actually one of his training center and universities. And Jackie asked me, like, what trash can we recycle? And I asked him in return, what are the trash that's in the movie industry that's actually piling up? DVDs. No one watch DVDs anymore. Lots of DVDs. So DVDs. So this all exterior is actually made from recycled DVDs. Okay, and then you can see the trash pressos. They're actually doing the production on site. Okay. Can we do hotels? Yes, we can. Okay, so this is hotels. Multifunctional rooms inside, from the ceilings to tables, lamps, everything is there. This is our office in Singapore, in Orchard 28. Welcome to visit us in Singapore. This is a Temasek shop house. You can see all that furniture, the walls are also made from our recycled material. This is in Thailand. I think you guys probably seen some of these projects, but I think this is also made from 100% recycled polyester, 2,000 denier, architecture scale, strength, tensile. But what's interesting is we want to use the least amount of footprint to show off how green this park could be in Thailand, next to the airport. So I still can't spell the name because it's a very long name, but it has 8 columns. So what we did is we worked with, I think, Italian Thai. So they built 8 columns, okay? And what we have to do is we have to come up with 8 canopies covering 3,000 square meters. It had to be constructed in 1 day. So this is 1 day of. But I mean, I think the client is really amazing. The client is the one who first got something like this in Thailand, in the world, get built. So the client is the one who says, just do it, and they have a guts and still sitting there. So welcome to visit there. Okay. And it's actually powered by the air. The air is also powered by a digital sensor. It's also powered by the sun. So you see the whole structure is adjusting to the crazy rain that's coming to Thailand in the afternoon for 2 hours, and it's adjusting to the wind, okay? And Starbucks. So Starbucks waste into chair frames, into the skin of a material. Do you notice that all our design is everything is single material and all are mechanically locked? So every piece of material can be separated only with your hands. Okay, this is a mechanical pattern that we have. Everything is, and this is our office in Milan. So you want to show you, we can take all women's sweaters from Eileen Fisher. We built a machine to recycle all the sweaters. We turn that into beautiful carpet and tapestry, okay? And for all the material in there, from the artwork, working with different artists to come out of these. So there's a lot of people, so we cannot all go to Milan. This only have 5 bedrooms. But for the next time, for those, welcome to visit us and welcome to stay there. We want you to sleep in trash, to feel the. By the way, this is next to Duomo. It's next to the Sforza Castle. It's like in the middle of a city. So welcome to be there. And there is a lot of very expensive fashion waste from Como. There's a lot of beautiful textile, silk, wool, and all that is fashion waste, and we collect it, we turn out these beautiful chairs. So hopefully we can see you there next time. So, all right, so how we get a lot of this innovation, we also have to work with a lot of international, because why sexy is so important, I think. This is because sometimes we work with the bosses in Xenia Group, right, and in Bonotto, the most highest end textile supplier in the world. When they touch some of our products, the first thing they say is, that's not sexy. I'm like, what? Why? That's not luxurious. I'm like, okay. And then even though you have all the engineering capability, you don't have the feel for what is sexy because there is a whole culture that built around what is sexy, right? So that's why we work a lot. That's why we are based in Europe. That's why also to be able to capture what is that desire of consumption through their learning, okay? And that we are collaborating together. So the last thing is, for example, this project, what's interesting is we work with Jackie Chan to collect the trash from the source of Mekong River. Okay.
Explorer and structural engineer.
At 4,500 meters, okay, we went to collect the trash at the basin.
Eco-friendly innovations and cutting-edge green technology.
And have a portable recycling system on site.
Green Heroes. Wednesday night.
Zero footprint.
On National Geographic.
Battery has footprint, by the way, but I mean I can't say, but it's solar power. Okay. All the water reverse osmosis, all the air is internally captured. So you can we are producing tiles for the school. So we built a school with Jackie, with the trash we collected locally. So hopefully we can do that with your ocean plastic campaign. The last thing is, what is possible, and sometimes you have a lot of failure. So this is the last learning I'm sharing with you guys, is failure is awesome. Okay, it's also very painful. So this boat actually sank, okay? So, and it happened to be next to a National Geographic event. They're trying to launch a boat made from trash, but we try to use WPC. But as you can imagine, if you have organic fiber inside, the first day is okay, 2 days is okay, the third day, the organic fibers absorb the water, and this picture is when the boat is got so much water saturated in the nose. Right before the Nat Geo event, the boat was actually looking like this. Okay, that was funny. So that was actually being taken out to dry, okay? So because of that failure, we decided to do something crazier. So we decided to invent a material to be able to do something crazy. Okay, so then we decided to do airplanes. So this airplane is still sitting in our office. We're still trying to, and supposedly it's going to turn into a Nat Geo show, but hopefully it might be me falling off the airplane. But I mean, I just want to state that if you look at this as a necessity and the urgency, and you put your life onto it, right? We can make it work, you know? So that's it. Thank you so much. I'm supposed to introduce my fellow Nat Geo explorer who just came back from a crazy trip that's actually doing the water pollutions and the plastic pollution survey across the Ganges. Yeah, and her name's Lily Gold, and she's going to be speaking after this, right? Thank you.